The views expressed in this interview are those of the individuals and do not reflect the official policy or position of the U.S. government, the Department of Defense, the U.S. Navy, or the Naval Postgraduate School. Welcome to the Trident Room, brewer of stout conversation, unfiltered and on tap. On today's episode, Trident Room host Mike Wish sits down with astronaut Steven Lindsey.
I want to fast forward a little bit to your experience with the first GPS-guided bomb, which I can only imagine was just incredibly impressive to watch. It's notable that you had the foresight to recognize the future applications of that technology, but did you really have a sense for just how much GPS was going to transform not just warfare, but even our everyday lives?
Watching that bomb drop, what amazed all of us at the time, at the time we were testing the state-of-the-art smart weapons that the Air Force had. We did a lot of smart weapons work, but they were, TV-guided, IR-guided, laser-guided bombs, different things like that, missiles and things like that. But I had never, ever seen a bomb dropped that you could actually drop through the clouds where you couldn't see the ground and actually hit a target.
Right.
I'd never seen that done and hit it very accurately. And to me, that was a game changer. But honestly, at the time, I was thinking, when we got GPS, and the first time I flew that F-16 with the GPS in it and saw what it could do, I was really thinking more along the lines, gosh, now I can fly, low altitude, low level to the target. I don't have to go clock the map to ground and read maps very carefully and spend most of my brain cells doing that. Instead, I could rely on a very, very accurate navigation system that would take me to my objective, my target, and I could focus on employing the aircraft rather than spending all my time navigating the aircraft. But I thought about it, sure there are going to be civilian applications like, maps, for driving your car from point A to point B. But if you think about all of the things that GPS does today, I didn't have that big of a picture. I don't think any of us could have imagined all of the applications for something like that when it first came out.
Well, from my own experience with the Marine Corps' rocket artillery system called HIMARS, every munition we employed on that system in Afghanistan was GPS guided. Even when we had cannons with us, they were firing GPS munitions most of the time. Now, much of that was driven by the nature of that particular conflict, but it's obvious just how important that capability is.
Yeah, and where I go back is when you look at the you go all the way back to World War II. Look at the combined bomber offensive, where we tried to use B-17s and B-24s and stuff to bomb Germany and Japan and take them down. They would send waves of 1,000 bombers to hit an oil refinery, and they'd get partial damage of it. And the doctrine was we can do this precision bombing stuff, and we can avoid collateral damage, pinpoint, hit the military targets, and meet our objectives with very little collateral damage and be very efficient at doing it. But the truth is, they didn't have anywhere near the technology to actually pull that off. But where you saw that doctrine come to life was in the first Desert Storm, with when you had the one bomb, one target. You watched what the Abrams tanks were doing out there, one shot, one tank. All of those sorts of things, all that technology came to fruition, and the doctrine they tried to establish in the 30s and the 40s was finally achievable through the technology by the 1990s.
Well, from my own experience with the Marine Corps' rocket artillery system called HIMARS, every munition we employed on that system in Afghanistan was GPS guided. Even when we had cannons with us, they were firing GPS munitions most of the time. Now, much of that was driven by the nature of that particular conflict, but it's obvious just how important that capability is.
I think it was very comparable, actually. Coming out of the flight test world, where a lot of times, I'd be doing a missile shot that was when you add up all the assets and all we were spending to get this thing just right, the geometry just right, the parameters just right. $20 million shot, and the pressure that was put on the pilot to to be very, very precise in the flying and get the data point that we needed to certify the system so we could hand it over to the warfighters. There was a lot of pressure with that. When I went to NASA and started training to be a shuttle pilot, and those missions are similar. They're very pressure filled. You know, you got to deliver, you got to perform. You're at risk doing it. You know, I got in the cockpit, you know, ready for that first flight, and it felt to me like a hazardous test mission, like I'd been on before. I was obviously a different environment, and you know, as far as the actual experience of launching as a pilot, you know, for the first time, you know, I was used to flying high performance aircraft, but when the shuttle leaps off the pad and when the solid rocket boosters light and you're immediately at almost 3 Gs, except what's different is you're at 3 Gs, but you're going straight up while you're doing it. And you just got the impression of the immense power. She had 7.5 million pounds of thrust behind you. The immense power and acceleration going straight up. It was a wild ride. And the other thing that really strikes me from the first ride up was at about 6.5 minutes, and that equates to about Mach 14, I think. We typically flew, if you ever watched a shuttle trajectory, we flew heads down, and we did that primarily for load relief on the wings. We didn't want any air loads on the wings, putting the extra strain during the ascent. And once we got out of the atmosphere, at about 6.5 minutes, we would roll it, so we're upside down, we would roll the heads up because we would transition to communications with through teeter satellites instead of ground stations. And we were actually the first flight to do that, roll the heads up. And of course, you're completely upside down. The computers are actually flying, although you can fly it manually. And I had a bet with my commander which way it was going to roll, because if the computer thinks you're at 179.9 degrees, it's going to roll in one direction. It's always going to roll the shortest direction. If it's 181, it'll roll the other direction. And as it turns out, it rolled my way. And when I say by my way, it rolled so that I could see the Earth and he couldn't. And but I'll never forget at that point, and we were probably maybe 60 miles high at the time, seeing the Earth from space for the first time. I'll never forget that view and what it was like. And then, of course, 8.5 minutes, you're on orbit. You go from at the end of the trajectory, you're also at 3 Gs, and you go from 3 Gs, and then all of a sudden you're at 0 G and you're floating, and that's it. And then you're into this surreal world that you've never experienced before. So it was pretty cool, but I got used to it pretty quick. So.
In the episode with Jim Newman, he discussed the overview effect and how it impacts people differently. How did it impact you?
It really does. It does affect you differently. I would say, from various aspects, right? I think everybody ends up being more of an environmentalist after they go into space, because they see the planet globally. They also see it. They see the good parts of it, and they see the damage. You also get a different perspective, I think, internationally doing it. In particular, and maybe that's not so much about being in space, but there's the fact that our office was an international office. We had Japanese astronauts. We had European astronauts from multiple countries, Canadian astronauts, Russians, lots of Russians, and we got to know all of these folks, and we work with all of these other nations, and that also changes your perspective about people. And probably the most dramatic for us was I was a Cold War fighter pilot, and Russians were Soviets were the bad guys, and then 10 years later I'm flying with them in space, and got to know the people. In fact, a really quick Cold War story for you. So back when I was operational, it was all about the Third World War. It was the Soviet bloc against NATO. The fight was going to be in Europe, and we would all the pilots, we were all certified. It's called certified for missions, and basically we had our first mission or two for the Third World War already planned, and we would have to go plan that mission each year and brief it and certify that we were ready to go with the threats and everything else. And you may have to do something similar in your jobs. But we had to do that for the Cold War. And so my first flight, about a month before flight, we flew a Ukrainian astronaut, first Ukrainian astronaut on my flight, Leonid Kadeniuk. And Leonid had been a Soviet cosmonaut, and then when Soviet Union dissolved, he was a Ukrainian, so he went to Ukraine and became a Ukrainian astronaut. But in the Soviet Union, he was actually a fighter pilot and a test pilot for the Soviet Union. So he flew MiG-21s, MiG-23s, tested MiG-29s and things like that. And so my commander on my first flight was an F-111 pilot, also an Air Force pilot. And we were talking one night, and Leonid was pointing. We had a map of the world out, and Leonid was pointing at where he was based when he was flying, I think, MiG-23s. And he was a fighter pilot on alert, basically on their side doing the same Cold War, Third World War prep mission that we were. And when he pointed to his base, Kevin looked at his base and he said, "Leonid, your base was my target when I was an F-111 pilot." And the three of us were just sitting in that room. It was 2 o'clock in the morning. We were up late, goofing off. And the three of us just kind of looked at each other and said, "Wow, how has the world changed?"
Wow, how surreal was that?
Yeah, very surreal moment.
If only we could find a way to inspire that international spirit without having to send everyone to space, although that would be a really cool way to do it.
Well, and that's the other interesting geopolitical thing about space, and in particular the space station. You know, and we have our issues with Russia that are ongoing and continual, and they change and they ebb and they flow, and sometimes our relations get really bad, sometimes they get better. And I've watched this over the years, but in the entire time I was at NASA, and I know it's still true today, what was really interesting was our relationship, generally speaking, with the Russians, you know, as part of the space station, was always positive, and it never really changed, no matter what was going on the ground. And so it was one area that I think we have successfully cooperated with them and continue to do so. And it almost, like I said, it stays pretty constant, even though there's, you know, all of the other stuff that's going on with Russia that goes back and forth.
That's great to hear, and hopefully NASA will continue to be that anchor point, fostering a mutual sense of cooperation through discovery and exploration. Speaking of exploration, there was some recent big news from NASA with the Perseverance rover landing and I think an upcoming helicopter launch, which should be occurring in the next couple of weeks or so. Is that right?
Yeah, I think the last I heard is it's about 2 weeks, and so yeah, we're pretty excited about it. And in particular, the company I work for now, Sierra Nevada, our space systems group up here, we actually have about 18 subsystems on the Perseverance rover.
Is that right? Is that right?
And we've been on we've had stuff flying on every single interplanetary mission NASA's ever done in the last 30 years or more. All the rovers. If you saw the really cool video of the rover landing, the last part of that was where the rover was lowered down on a cable and set down gently on the Martian surface. We actually built the mechanism that lowered it, and so they talk about the 7 minutes of terror, which is the entry portion, and we're like the last 30 seconds of that 7 minutes of terror. So we were sweating that, and we did the same thing on Curiosity, so we sweat that one too. And we actually have a number of the mechanisms that are going to lower that helicopter onto the surface. We didn't build the helicopter itself, but a lot of the mechanisms that are supporting that helicopter is our company built.
That is really impressive. What strikes me as particularly amazing is not just the seemingly insurmountable engineering problems, but the number of people, governmental organizations, and civilian companies involved that all manage to coordinate and work together in a way that is conducive to designing, building, and testing these systems, which then go out and execute successful missions. Orchestrating all of those efforts must be a real challenge.
Yeah, it is, and it is a large team. It's a diverse team. You know, the management challenges they're big management challenges doing those sorts of things, and JPL is just really good at doing those kind of exploration missions. They've done a whole bunch of them, been very, very successful. So
I read an article yesterday, actually, that the helicopter has a cloth swatch from the original Wright brothers aircraft on board, which will now get the opportunity to fly on another planet.
yeah, it is. I read that too. I didn't know they'd done that, but that's really cool that they got I guess, a piece of the fabric that wrapped the wings, the Wright Flyer, on there, and they're. Yeah, and the technology is really interesting. The helicopter only weighs about 4 pounds, and it's got counter-rotating blades, and they're really large blades, only lifting about a 4-pound payload. But the atmosphere on Mars is so thin that they got to. So it's going to be really interesting to see how it actually flies. Hopefully, their predictions on the density, altitude, and all that kind of stuff are correct.
Yeah, in college I studied applied physics and had the opportunity to take several aerospace engineering courses. It's challenging enough to build something that can fly on Earth. I can't imagine the hurdles in trying to design something to fly in another planet's atmosphere, especially when you can easily test your aircraft in those conditions. So in your current work now, you had mentioned the Dream Chaser. Can you tell us a little bit more about that project?
So Dream Chaser is what we're building. It's called Dream Chaser, and it's essentially it's a lifting body spacecraft. So what I mean by lifting body is, if you look at the space shuttle and X-37, those space planes are winged spacecraft. We're a lifting body because the vast majority of the lift in the atmosphere that we produce is generated by the body, and only about 30% by the wings. But it's essentially it's a mini space shuttle. It's designed to carry, in this case, our primary contract that we're working on right now is to provide science and cargo back and forth to the International Space Station. So we have a contract with NASA. We're in production on the cargo version now. We're going to fly next year. But we also have done work in previous contracts on the crewed version. We continue to build a crewed version that's designed to carry up to 6 people on either free flight missions to low Earth orbit or up to space station. Where it comes from is it started as something called the HL-20 that NASA Langley worked way back in the early 80s. They worked it from about 83 to 95. It was designed to be a crew transport to the space station. It was going to replace the space shuttle, much smaller than the space shuttle. But then it kind of died in 1995, and then around 2009, 2010, our company went to NASA, and we since it was sitting on the shelf, we asked, we'd like to do a technology transfer because we'd like to develop this into a lifting body spacecraft, because we see the future of commercial space flight, and we think a lifting body spacecraft that can land on a runway anywhere in the world is the way to go. And so that's where it came from. Its original roots, believe it or not, actually come from a Soviet program called the Bor-4, where they flew a couple of one-orbit flights with these little demonstrators that shape is very similar to the Dream Chaser at 50% scale, and they were testing thermal protection systems for their Soviet Buran program, which is their space shuttle program. And so that's where it actually originated. And of course, their Bor-4 originated from our lifting body program that we had at NASA in the 60s. So anyway, it's funny how the technology evolves and comes around. And so we're working on a cargo version and a crewed version for that. I'm going to fly next year. Hope to fly crew, and we're really looking at the future. And the future is NASA is going to go focus on exploration. The space station eventually will be decommissioned when it wears out. NASA wants to focus their budget on exploration, and they're looking for commercial companies to take over low Earth orbit, essentially transportation and destinations. And so we're actually working on both pieces. Dream Chaser for transportation for the whole world. Our vehicle is specifically designed with things like no toxic fuels on board, so that we can land anywhere in the world without special equipment, reusability, quick turnaround, low operating costs. We're taking advantage of the reduced launch prices that continue to occur around the world. We're also building a destination, believe it or not. We have a program with NASA we're working on right now, an inflatable habitat, which is unique because it'll fit inside of a standard 5-meter fairing rocket. And the prototype we have in testing right now with NASA expands to 27 feet in diameter. So you can get a whole bunch of volume in space for people on a single rocket launch. And so with our Dream Chaser Nat, we hope to provide commercial transportation destinations, quite frankly, to the whole world in the future. So that's our big picture vision.
That's awesome. I seem to recall at one point, perhaps in a popular science magazine or something, that airlines were very interested in lifting body aircraft due to their efficiency and fuel savings. But as I recall, one of the limiting factors was the cost of construction, and that, at least at the time, it was just much cheaper to build the cylindrical tube of the airliner at scale.
And I suspect that has some to do with it. But I can tell you that in the world of the way manufacturing is going and the emphasis on composites, complex structures, our vehicle's all composite. With composites these days, you can do a lot of things very cost effective and very strong that you couldn't do back in the day. And so I would say that the technology advances and additive manufacturing, all those things are in the digital engineering that I'm sure you're hearing about. All of that is really revolutionizing how you can design and build, complex shapes, if you will. So it's changing.
Obviously, one of the major changes that has occurred over the last decade plus is the huge influx of civilian and commercial interests in space exploration, research, and soon for consumer needs like tourism, for example. Do you feel that the area of space is becoming very competitive, or is there still a sense of cooperation or unified purpose there?
I very much think we're past the tipping point, and I would say that it gets more competitive every hour of every day. And it's really, if you look at, let's take one industry, the small satellites and the proliferation of constellations. You look at OneWeb, you look at what Elon's doing with his Starlink and launching, 1,000 satellites in orbit, and you're seeing a huge commercial market developing. You're seeing multiple companies, multiple rocket providers, prices coming down, and access to space going up. So I think we're at the cusp of a boom, and we're in this transition. And launch vehicle pricing is probably one of the bigger drivers as the price to get to space. Because it takes a lot of energy to get to space to get up to Mach 25. But as the price goes down, the access and the number of people that want access and want to do things in space goes up. So I think we're actually past the tipping point, and we're headed rapidly into a pretty crazy commercial era.
So what was the motivation behind going to space previously in terms of experiments and research to conduct? And I ask because as we go forward, there is going to really be a commercial market for those type of interests.
Sure. Well, so I would say NASA, at least from the NASA perspective, we've been trying to commercialize space for a long time. Even in the early space shuttle missions I was flying, we had commercial companies flying research payloads on orbit. I'll give you one example. On one of my flights, we flew a payload for a company that flew a couple of flowers, believe it or not, in space, and they were doing some zero-G research on that, pulling the fragrance, and actually developed a perfume out of it. As an example, I just saw an article yesterday on the space station. There was a company that flew some wine in some special steel bottles up there to analyze the chemistry and what happens in a zero-G. Can they make a better wine out of it, and things like that. And I just read some article where they brought all that down, and these wine experts were doing a wine tasting, comparing the same wine that had been on Earth to the wine that had been aged, for 6 months or however long it was up on space station. So there's been a pull for commercial, but it's been limited. I can tell you there's been huge emphasis commercially in the biopharma region. One example is protein crystal growth, something we've been doing for years. Typically some cancers and flus and different types of diseases, it's a protein crystal is the shape, and they try to grow. So the way to think about it is you have this crystal, and you want to look inside this crystal and understand the structure of the crystal. And I'm certainly no biochemist or anything, but I'll explain it in pilot talk. So you want to look inside this crystal and understand its structure. And if you can understand its structure to a great detail, you can figure out a remedy for it, or a cure for it, or a cancer medicine to go attack it. And think of it as looking at the inside of a lock and being able to design a key to open that lock. The problem with growing these crystals on the ground is the gravity so much affects them. It crushes them. And so you get a misshapen, small, difficult to read crystal. You take that same thing and you take it up into a microgravity environment, you can grow that crystal maybe 10,000 times larger, and it has perfect shape because it has no forces acting on it. Right. Doing that sort of research, which we've been doing for years and years and years, they've developed some vaccines for various flus and different things like that out of it. And so that's a huge area. Biopharma, I see that commercially in the future. Manufacturing in space. Right now, I think it's more manufacturing things that you can manufacture purely in space, study, and then figure out how to replicate it on the ground because it's too expensive to manufacture in bulk in space. However, someday I think that will be possible as well. One of the other examples of stuff we did is we looked at metallurgy. We had a furnace on orbit. I did some furnace work. We'd have these metal samples and heat up these metals and let them cool and see the structures they form. And basically, we were developing and improved alloys for jet engine blades and different things like that because of the microgravity environment. So I think the future markets will be a lot in the manufacturing, the biopharma. We're seeing that now. You see tourism starting to heat up. Right now, it's just high net worth individuals, but as the price goes down, I think you'll see that increase in the future. Satellite servicing, obviously the satellite stuff. I think everybody knows that from a security standpoint, everybody's in space now, and we have a huge national security need in space as well. That we have to make sure that we have this commercial economy and all of these things happening in space. And we have things like a great GPS constellation. Well, we don't want that to be denied to us. So that's a big area. That's not a commercial area, but that's certainly an area that everybody's paying attention to. So I just mentioned a few, but we've actually done a lot of market studies to look at all of these things because, again, we see commercial low Earth orbit in our future, and we want to make sure we understand those markets and create those markets so that when we have our products in space, we have plenty of demand for them.
It's getting crowded quickly, isn't it?
It sure is.
Especially as the Space Force stands up. I'm considering resigning my commission to be a Space Force door gunner.
A door gunner, yeah.
Well, I have two final questions for you as we finish up here. The first is, if you had the opportunity to go back to space, would you? And the second is, what advice do you have for the officers and students at NPS and AFIT?
Oh boy. Okay. Well, the first one, if I had the right opportunity to go back up in space, I would. If I were going to go back up in space again, I really want to be one of the ones that goes to the moon. But I don't think that's ever going to happen. Now, if you ask my family if I'm going to go up in space again, they would tell me no. I think one of my daughters told me a while back, said, "Dad, if you go up and," because I originally came here. We were working on the crewed version. They originally hired me to do the flight test on the crewed version and do that first flight in space on the crewed version. But my daughter told me, my youngest daughter, I think, told me, says, "Dad, if you go up in space again or try to," she said, "I'm going to kill you and use the insurance money to buy a house." So I think my family, every time you go in space, I think we all know the risks. It's and of course, they had friends and some of my best friends were on Columbia, and so I think the risks associated with it. My family has a different idea whether I should go in space again. Let's see. And the second question was advice. Boy, I don't know. The first thing I'd say to you guys that are going through, guys and girls that are going through grad school is, it's a great opportunity, and it may be painful right now because it's a lot of work, but what a great opportunity. I can tell you that, and I actually went back and spoke at the AFIT 100th anniversary back in 2019, and I told them, I said, if I hadn't have gone to AFIT and had that opportunity, being as successful as I was as a test pilot, and certainly getting to be an astronaut later, and even what I'm doing today, all of those things that I did since that time would not have been possible if I didn't get the opportunity to go there. And so, what I would tell all the all you young folks that are going to school right now is embrace the opportunity, learn as much as you can, look for opportunities to apply it. It's part of the journey, and you will not regret doing it, and it will pay off in big dividends. The other thing I tell you is it's easy. It's good to have really hard goals. The one thing I tell school kids about, because I get this question a lot, and what I tell kids is that I was really fortunate to be an astronaut, but what I tried to do in my career was pick a journey that I really wanted to be on and do those things that I wanted to do. And often the astronauts or people that want to be astronauts come to me, well, what do I need to do to be an astronaut? And I said, what you need to do is excel in what you love to do. And don't choose things to do because you're focused on a goal, particularly if you're choosing to do things that you don't really want to do or you're not interested in. So, be passionate about what you're doing, do the best you can, but most importantly, enjoy the journey along the way. Because for me, I was very fortunate to become an astronaut, but when I applied, I didn't think I was going to get selected, and if I hadn't got selected, it would have been okay. I would have been okay with it. And so I didn't hang my whole life on that, and I was just fortunate enough to get the opportunity. So I guess that was kind of a rambling answer, but that's kind of how I view life.
No, that's great advice. Thank you so much for taking your time to be with us on the show and talk to the students at NPS and AFIT.
Yeah, I have too. It's good to talk to you. Tell your dad hello for me.
Thanks for joining us in the Trident Room. This episode was recorded on March 25th, 2021. For more information about today's guests and topics, please visit the show notes. The Trident Room has been brought to you by the Naval Postgraduate School Alumni Association and Foundation. For questions, comments, and suggestions, please email us at tridentroomPodcastHost@nps.edu and find us online at nps.edu/TridentRoomPodcast.